Good morning, everybody. It's my honour to be here this morning to represent Martinez Gamuda. My name is Ronan Collins. I'm Irish, which is what the IR stands for in my title. It actually means engineer in French. I'm going to tell you a quick story about some of the people that are working for Gamuda. This is John Lim, and if you're here this morning for Dr. Oi's presentation, you may have seen John's picture. John is the engineer that wrote the software for our automated TBMs. And I met John about a year ago, and my reason for meeting John was I was asked to go and look at a project where they were using QR codes to track the delivery of the tunnel segment linings into the tunnels. So my background is in information management, 3D modeling, project management. So I was helping John out to try and figure this out. And he told me about this automated tunneling machine. And it was like a secret. Nobody knew about it. So I said, mate, you got to get out and tell people what we're doing. So they put together a case study. They put it to the International Tunneling Association. And last week, John and the team and his colleagues won an international award for creating the first self-driving tunneling machine. So a very cool piece of technology and very, very productive. So my presentation this morning is about technology, but it's actually about the people behind the technology, or more importantly, the people in front of the technology. We believe that we have to empower the staff to innovate, and we believe that celebrating their success on these kind of events is a very good way of motivating people to come up with bright ideas and share them in the organization. So I'm going to use a case study from Kuala Lumpur in Malaysia this morning. This is the MRT project. There are two projects. There's a Line 1, which we've already completed and is operational. This is one of the Line 1 trains. And I'm going to talk about Line 2. Line 2 is a 51-kilometer alignment with 13 kilometers underground through the inner city of Kuala Lumpur. There are 17 construction sites on the alignment, involving 10 stations and 7 ancillary structures. These are all major civil engineering projects in and of themselves. And when you combine them into a 13-kilometer design and build contract, it's one of the biggest civil engineering projects in Asia. We have been extensively using photogrammetry, which is using drones and helicopters to create 3D models of the sites. So this is an actual 3D model of the inner city of Kuala Lumpur, showing the locations of the stations. And you can see, this is the famous Petronas Towers. You can see the sites are in a very dense urban environment. So one of the problems with this project is logistics. And I'll come back and talk about some of these particular stations in a minute, but this gives you a very good sense of the scale and complexity of the project. Now, this being a construction conference, I'm going to be speaking about the use of technology on the sites and how we've gone from the BIM design side to the actual construction delivery side. To give you a sense of our progress, we started this project in 2015. I've been personally involved since then. And we're currently through construction works at about 62%. And we are on track to be, excuse the pun, we're on track to be up and running and operational by 2022, sometime between Q1 and Q2 2022. So we've still got another 2 years of solid work ahead of us. Now, one of the strengths of this particular project is the client's involvement. At the very outset, the client set out to achieve BIM level 2, and they were using the UK Crossrail as a template and as an example of leadership. So we set out to basically replicate what was achieved on Crossrail. And we tried to do that without the downsides of Crossrail with the delays and everything else. So we're trying to do a better job than Crossrail, which is no mean feat. So the objectives of the client was to achieve BIM level 2. So we appointed AECOM as the lead consultant, and they appointed the design team, and they were all contractually obliged to work in BIM. So this is one station that was designed in Revit. This station is called Titiwangsa, and it's an interstation between an elevated rail, monorail, and an elevated LRT. This is the architectural model. So this was designed and created by the architects. You will note that it's only the architectural elements. All of the structural elements were modeled, designed in detail by the structural engineers, separately from the architects. So there's steel, there's diaphragm walls, there's secant board piles, and an entire concrete structure inside. And these stations, being underground stations, are heavily serviced, and you can see the complexity of the building services and MEP services in this. This is the MEP system, so this is the actual air conditioning, electrical, and fire. We've also got all the rail systems. So we have the track systems, we have the comm systems, we have the security systems, and these are all modeled by the system-wide contractors. So one of the challenges with this process is, how do you put all these models together? How do you find coordination issues? How do you solve design problems? So we have an entire federated model approach, and this is just what it looks like at the detailed design stage. So this is pre-construction. This is the level of detail the designers achieved in the lead up to the project. With these tools, we can cut sections, we can look at plant rooms, we can look at specific details, and the models give us a very, very clear insight into what we have to build as a contractor. So in terms of the use case, the project is divided into 4 or 5 key phases. We're currently doing the final CSDs, which is the site-based coordination. And you can see our uses of the model. So we used it at the beginning for doing design, architectural design, spatial design. We then used it for all the design authoring. So all of the construction drawings have been produced from the models. This is not a 2D back to 3D process. It's a 3D driven process. We say model first, draw second. And then we've done all of the design reviews, all the coordination reviews, all the interface management, all the interface reviews using these models. And when I say interface reviews, I'll get to that, the complexity in a second. But the objective of the MRT underwriting all of this was to capture all the asset required to maintain and manage the actual infrastructure when it's built. So I'll tell you how we've done that as we go forward. Somebody's moving a lift. So this is a overview of all of the interfaces that we have to manage. And as a design and build contractor, it's on our shoulders to coordinate all of these interfaces. So you can see in an underground environment, the sheer number of interfaces and the complexity of interfaces is mind-boggling. So we use the models and the model breakdown to identify all the different interfaces and identify all the coordination issues that had to be done. So this is an example. This is one of the stations. This is Chansao Lin. So you can see we have all the models created and all the coordination done. We've also done it for all the intermediary structures. So we got escape shafts, we got vent shafts, etc., etc. So this is what the consultants produced, and our challenge as the contractor was how do we use this to actually build the infrastructure? So going back to the key point about getting people to innovate, we empowered our own staff in our design office to first figure out how do we manage the coordination process. And I want to introduce you to one of the characters. This is Rahimi on your left of the image. Rahimi is a larger-than-life character. He is an absolute enthusiast when it comes to Revit and BIM, and he has completely driven a process for coordination management. I'm going to show you how he's done it. How many people here have been involved in a BIM project of sorts? Who's here seen a Revit model or a BIM process? We've got a few people, right? You all know, having looked at those models, how much effort it goes into finding issues and solving issues. And we had a process on the project where we would start through this workflow, creating models, identifying issues, running workshops, tracking all the issues, issuing reports, and then recycling this on a 2-weekly basis. It's like a washing machine. The design consultants go through this every 2 weeks. Sometimes they fix the issue, sometimes they create more issues, but this goes round and round and round and round. And it's very difficult to manage and track. So Rahimi and his team set about creating a system where they first of all scheduled all these workshops in a rigorous pattern, so they were all calendared out. So every 2 weeks, everybody knew where they had to be. And each one of those boxes is a station site. So every 2 weeks, if you were on a station, a specific station, you knew where you had to be. The workshops were done in small teams. So we didn't have 50 people in a meeting room. We had the small team of decision makers. These are the engineers. The gentleman in the right with the yellow is the client. This is the coordination engineer here, and these are the design engineers working on the models. So we had very specific groups of people looking at very specific issues. And at the beginning, we would find things like cable trays running through escalator pits. Now, good luck trying to get out of that station if there was a fire with all those cable trays over your heads, right? So that had to get fixed. We got right down to solving pipes clashing with ductwork to make sure that we had no MEP coordination issues. So all of these issues were tracked. They were numbered. They were assigned to someone to solve. They were given a date by which they had to be solved. It was all project managed. And this was all done by Rahimi and his team using a platform called BIM Collab. So this is an online system where we can see station by station, consultant by consultant what's happening, and we can monitor their performance. So we would get a dashboard, we could see all the issues, we could see who was assigned to those issues. And the most interesting part of this, because we had 10 stations, we could track different stations against each other. So Rahimi created this tracking chart, and these are the number of issues per station, and you can see how they're comparing. So we could see which stations were doing better than other stations. Very useful when you've got competitive teams, when you want Team A to do better than Team B, and going, mate, you're going worse than they are, you've got to up your game. So this all came from Rahimi. Now, one of the things that we had to do very carefully was manage exchange of information, exchange of models, exchange of drawings. And to do that, we relied heavily on ProjectWise. So we had staff working in Kuala Lumpur, Singapore, Taiwan, Hong Kong, Philippines, and we had 2 offices in India. So we had an office in Delhi and we had an office in Calcutta. All of those offices needed real-time access to the models on a daily basis. So we used this platform to exchange all the information. Now, I've told you it's a very large project, but to give you a sense of the scale in terms of data, get this to work. This is the actual data dashboard from the system. This is probably from a year ago. There's over 2.3 terabytes of information on the platform. There's something like 75,000 model files, right? So when you get to that scale, the structure of the information, the organization of the information is absolutely crucial. And we've created a very sophisticated way of managing it by location, by discipline, by system, by models, by drawings. So it's very, very rigorous. It's very important that you don't let everybody come up with their own system. So on the scale of this job, we as the construction lead managed all of the information management systems. And we basically said what you could do. So we use the platform to share the models, the visualizations, the drawings, the specifications, the takeoffs, all the information that we needed to coordinate and deliver the project is on this platform. Now, we managed to achieve BIM Level 2 through Rahimi's efforts and his team's efforts. And the gentleman in the middle of this photograph is Mr. Nick Moorcock, who's Rahimi's boss. And Nick was in the UK recently. He picked up the certification from BRE. So MMC Gamuda are the first Level 2 BIM capable contractor in Asia based on our work on this particular project. So through our experience, through our knowledge, through our systems, we've been recognized by the BRE as one of the best contractors in the region for doing this. This all goes back to how Nick and the team managed the staff to innovate. Rahimi came up with these systems. Rahimi's teams came up with the ideas. Our next challenge, having gathered all the information, is to capture the information that the owner needs for the operations of the facility. And it is actually a very complicated task. It's made complicated by the fact that the MRT have never done this before. They don't actually have a full understanding of what data they need. So we had to spend quite a long time planning out what information we had to gather and then delivering that information to them in a structured format. So to do that, we've basically adopted Uniclass as a classification standard, and we've basically trained all the consultants to produce models that are properly classified. And it's not straightforward. So you have to classify things in 4 different ways. There has to be a classification by where it is. There has to be a classification of what room it's in. There has to be a classification for what system it's part of. And then there's a classification of the actual product. So when you go through an example, this is the entity or the station. So each station is unique. They have a unique code. Inside the station are the spaces. So this is a platform space. It's given a unique code. So if an object's sitting in that space, we can find it. If an object's sitting in a different space, we go looking for it in the other space. We then need to know what system it's in. So we need to know whether it's a fire sprinkler system, whether it's a mechanical system, whether it's an electrical system. So everything has to be properly categorized in that system. And then once we get down to the individual components of the project, we then have products. So whether it's an air handling unit, whether it's a chilling tower, whatever it is, there's a code for that as well. The challenge with this is that the design consultants have never had to do this before in Southeast Asia. Getting designers to put in this data and put it in correctly is a pain in the... So this is very, very complicated. So what we've done is we've taken a lead from our friends in the UK. If you talk to the guys on Ausrail, they will give you one key nugget. Put the data on a diet. Capture the least amount of information possible, and then you can audit it, then you can track it, then you can check it. So what we've done is we've identified the list of things that we're only capturing information for. So everything on that list, we're capturing information for. If it's not on that list, it's not being done. So we're not capturing information around ductwork, cable trays, piping. We're only capturing information about the actual things that we have to replace and manage. So we've managed to convince the owner that that's enough. No more, no less. And then for each one of those devices or LRUs, this is the information we're going to capture. So we're giving them the classification, the tags, and everything else. So we've come up with a data structure that we know we can capture, that we know we can deliver, and that we know we can audit. So that's the asset management side. And now I want to talk about the site side. So the surveying team have been the champions in terms of innovation on this project in more than one way. So here you can see Faiz and they're operating a drone, and I'll come back to the drones in a minute. The first thing that we did on the project before we did any design is we scanned all of the existing sites using laser scan. So we have 3D point clouds of every single location along the entire alignment to this level of detail. And then we use those point clouds to create as-built Revit models, in this case a structural model of the monorail, that we gave to the design consultants and said, this is the as-built model at this station location, now crack on and do the design. Because we know that the as-built records are not good enough. We know the consultants will just take photographs and not look at the detail. So our survey team have created these three-dimensional point clouds and the as-built models of the site. And then about 18 months ago, Nick Moorcock, who I just showed you the photograph from, Nick is actually a qualified UAS pilot. He's actually qualified in the UK to fly drones. And we set about doing some research about how could we use drones for surveying of the sites. So this is a drone plan for surveying a particular site. This is a drone videoing another drone doing a survey. So we have two drones doing the work, right? And we've done this for this PR campaign. So essentially the drones are going along and they're taking photographs. So they take a photograph basically pointing straight down. Each photograph overlaps the previous by 70%. So you're basically getting thousands of photographs per survey. And those photographs are very high resolution. So we're talking about 5.4 by 3.6 megapixels. And if you look into this little yellow box, this is actually myself and Nick doing one of our pilots, so you can get a sense of scale. So this is the scale that we're operating at in terms of photographs. The drones typically operate at about 100 meters. To make the technology work, we also have to have basically ground control points or reference points. So here we're basically using a target that the photographs pick up, and they're recording the GPS coordinates of that target. And then what that means is when we create the 3D mesh from the photographs, it's in the site coordinates, and we can then use that for site measurement, site surveying, etc., etc. So the way we operate, we have a very strong safety-first approach. So we operate in strict areas for the drones. So they're operating in areas where there's no construction activity. They're checking the drone to make sure there's no problems with the actual device before we fly it. We don't want it falling out of the sky into the site, or worse, into the public. And then we've trained. Currently, we have 30 pilots who have been given special permission to fly on the sites. These guys have been trained, they know the safety and everything else, and they work in pairs. So every time we operate, we have one guy operating the drone, or girl, and we have one spotter. The spotter is on a radio in direct communication with the site manager and the safety officer. So there's a complete control over what's going on with the survey. What do we use these for? Well, the first thing you can do is you can create proper orthomosaic images. So you can create proper ortho images, and those images can be used for area takeoffs, they can be used for progress reporting, and we've been using them for GIS. And I'll give you an example of the difference. This is an image from Google. So if you go on Google Earth and you look for a site location, this is what it looks like. If you compare that to an ortho, the ortho is a proper view from above, and then we can plot the TBM path through that. So we can actually see what property lines we're going under. So it's very, very powerful from a desktop surveying perspective. We're using it for progress reporting. So this is actually a sequence taken every 2 or 3 weeks of a particular site, and you can see the excavation going through in sequence. So we have surveyed every 2 or 3 weeks, and we have basically a progress model. Now this is a 3-dimensional model that's dimensionally accurate to the survey grid. So this is not an image. So people see this, oh, this is just photographs. This is a 3-dimensional model. I can measure the depth of the excavation in any one of those instances, or I can measure the area or the volume. And then some of the team that's working with Nick, we figured out how to link the model from the survey to the BIM. So we could actually see that's the basement excavation we have to reach, and we can compare our progress against our target. So we actually have basically a known destination we have to get to, and we can then use the survey to see how close we're getting to it. So this is a very useful way of showing to a client how far we are away from actually completing an excavation. And this again is the model in this corner. So anybody who's familiar with these, you'll know that you can use these models for takeoff, so we can actually measure linear dimensions. But more importantly, from the surveyors, we can measure volumes. So in this example, the operator is basically pulling out an area of the site, and they want to work out a cut and fill for creating a level deck. So here you can see them setting the boundary, and then the operator will set the parameters. So we'll use basically as a 28.5 meter level that we want to create. We'll set the grid, and then the software will tell us that we need to remove 11,500 cubes and fill 9,500 cubes. That is transformational when it comes to surveying. And it's transformational because the survey takes no more than 2 hours. and the post-processing on the computer takes less than half a day. So you can go out on site, survey an entire site in a couple of hours, and have this level of information available to the engineers by the end of the day. And there's no way around it. If the surveyors tried to do that, it would take them a week. And by the time they were finished it, they would have changed the levels and everything else, the calculation would be gone. So this technology is transformative. Now I want to introduce you to two more characters in this process. Tony Joseph is our GIS manager, and this is Mr. Pois, who's our surveyor. Mr. Pois has been pushing the guys to use the drones for as many ideas they come up with. He's the one that's encouraging the innovation. He's the one enabling the innovation. Tony has transformed the delivery of the information to our engineers, our project managers, and even to our client. Tony is a GIS expert, and for those of you who know GIS, to me it's a two-dimensional mapping platform, but it's much more than that. Tony's been able to take all the models, use GIS as a gateway. This is a web browser, so this is Chrome. You can go onto the web, if you know the URL. You can access the model from the drone survey and the Revit model from the BIM team, and you can overlay them on a browser. You don't need to have Revit, you don't need to have Navisworks. All you need to have is an internet connection and a password. And you can get a three-dimensional model of your site at a key point in time, and you can even go back and look at historical records. So we have project directors who don't have the time to visit 17 construction sites, who will sit down with a team of people and go through these models in an office environment. So Tony has been able to transform the way we deliver the information to senior staff. Okay, and we see that as very, very important. And one of the other things that Tony has done, which I think is really cool, is Tony has taken the information from the tunneling machines. So we're running 8 tunneling machines. We know in real time where they all are. If you go on the GIS platform, you can actually see all the tracks of the TBMs, and you can tell exactly where they are underground. And you can see here, this is the orthomosaic image, and you can see the red and blue lines indicating the tunnel drives, and they will actually tell you exactly where the tunneling machines are in the actual underground space, on the platform, on the cloud, in real time. Now the last character I want to introduce you is David, and I think David's somewhere here. Where's David? There's David. David has been leading our digital site, our digital forms business, and David is now based here in Sydney, and he's helping us build the Martinus Gamuda business. David has helped train up a huge team of people, hundreds of people, to use what we call our digital forms or paperless construction. And what we mean by this is that we've taken all the traditional paper processes on site, whether it's a progress report, a safety inspection, incident report, a quality inspection, all the stuff that you see engineers walk around with clipboards and bits of paper in their back pockets and all that stuff. We've taken all that and digitized it. So all of our inspections for all the construction sites are now done on iPads or Samsung devices. And all that information is captured in a structured format. So what we've started doing is speeding up all the processes on site. So if you want to get approval for an activity on site, you don't have to get a piece of paper signed by 2 individuals and you have to go around and look at them. It can all be done digitally. So you can fill in the form, it gets immediately notified to the recipient, they can sort it out and they can send it straight back. So we've sped up by a huge factor the approval process for works on site. But what's intriguing about this is we set out to digitize the paper process for 2 reasons. 1, to be more efficient, and 2, to capture the information much more systematically. Every time one of these forms is filled in, it's recorded on a cloud system. It can't be erased, it can't be eroded. We never lose the information. We lose paper all the time. But what we discovered is we achieved those 2 goals, productivity and security, but we've also unlocked something completely new, which wasn't foreseen. We're now using these systems to capture information for reporting. What we've realized is we can start running analytics on these reports. So we can start capturing historical information and comparing it one site to another site, 1 week to a previous week, 1 quarter to a previous quarter, and we can start to understand from a data perspective what's happening on our projects. So we're currently running an innovation project to look at data dashboards. In this case, we're using Cognos, IBM Cognos, in terms of how do we improve even further with the use of these digital forms, our understanding of what's happening on site. And our goal is to get to real-time progress monitoring using dashboards. Our current reporting is 2 weeks behind the activity. So if you get a report from one of our sites, it's about 2 weeks behind what's actually happening on site. And most people are used to that. You send a WhatsApp, you get the construction directory, puts together a few reports, you get a few Excel tables, a few Word documents, a few opinions, and you get a feeling of what's happening. This gives us real-time information of what's happening on a job site. This is what we're currently working on. So to wrap up, the key message here is that you can have all the technology you like, but if you don't enable the people to use it, you won't get these innovations. And it's my honor to stand here and represent the team of people who have done this over the last 2 to 3 years. They've won awards all over the place. They've won awards for the Tunneling Association, they've won awards from the software vendors, and we've started to get recognition through people like the BRE for our Level 2 BIM certification. So, thank you very much for your time this afternoon. If you have any questions, fire ahead. Thank you all very much.